Let's suppose that computer A wants to send a file to computer B. The file transfer program on A asks the file system to read the file from the disk. The communication system then sends the file, and finally, the communication system sends the packets. On the receiving side, the communication system gives the file to the file transfer program on B, and that file transfer program asks to have the file written to disk. So what can go wrong in this simple file transfer setup? Well, first, reading and writing from the file system can result in errors. There may be errors in breaking up and reassembling the file. And finally, there may be errors in the communication system itself. Now, one possible solution is to ensure that each step has some form of error checking, such as duplicate copies, redundancy, timeout and retry, and so forth. One might even do packet error checking at each hop of the network. One could send every packet 3 times. One might acknowledge packet reception at each hop along the network. But the problem is that none of these solutions are complete. They still require application-level checking. Therefore, it may not be economical to perform redundant checks at different layers and at different places of this particular operation. Another possible solution is an end-to-end check and retry, where the application commits or retries based on a checksum of the file. If errors along the way are rare, this will most likely finish on the first try. Now, this is not to say that we shouldn't take steps to correct errors at any one of these stages. Error correction at lower levels can sometimes be an effective performance booster, and the trade-off here is based on performance, not correctness. So whether or not one should implement additional correctness checks at these layers depends on whether the amount of effort put into the reliability gains are worth the extra trouble. Another example where the end-to-end argument applies is with encryption, where keys are maintained by the end applications and ciphertext is generated before the application sends the message across the network. Now, one of the key questions in the end-to-end argument is identifying the ends. The end-to-end argument says that the complexity should be implemented at the ends but not in the middle, but the ends may vary depending on what the application is. So, for example, if the application or protocol involves internet routing, the ends may be routers or they might be ISPs. If the application or protocol is a transport protocol, the ends might be end hosts. So identifying the ends in the end-to-end argument is always a thorny question that you have to answer first.